In section 3.1, we will begin our work with geometry. We'll start with the Pythagorean theorem. Almost every student, when I ask them what the Pythagorean theorem is, gives it to me in letters. A squared plus b squared equals c squared. What this means is that the sum of the squares of the legs is equal to the square of the hypotenuse. The hypotenuse is the side that's always across from the right angle, and the two sides that make up the right angle are the legs. So for my first example, we have 4 squared plus 3 squared equals x squared. 16 plus 9 equals x squared. So 25 equals x squared, which means that the length of my hypotenuse, x, is 5. For the second example, notice that in this case I'm actually missing a leg. So x squared plus 11.9 squared equals 14.7 squared. X squared plus 141.61 equals 216.09. And then subtract 141.61 from both sides. And we get x squared is equal to 74.48. Take the square root of both sides. And x is equal to 8.63 kilometers. I forgot my units over here. That was miles. The sum of the angles of a triangle need to add up to be 180. So in my first triangle here, 65 plus 57 plus question mark equals 180. So 65 plus 57 is 122 plus question mark equals 180. Subtract 122 from both sides. And so question mark is equal to 58. For this one, we have two triangles, and they are actually touching each other. These angles are what we call vertical angles, and they are congruent. So if we can figure out what this angle is, then we'll know what this one is, and then we can figure out what our question mark is. So 20 plus 40 plus, I'll call this one x, equals 180. 60 plus x equals 180. So x is equal to 120, which means this angle is equal to 120. So 39 plus 120 plus question mark equals 180. $159 plus question mark equals 180. Subtract 159 from both sides. And so question mark equals 21 degrees. The formula for the area of a triangle, if you know the base and you know the height, is 1/2 base times height. So in this case, 1/2 times 8 times 4.5. And that is 18, so the area equals 18 miles squared. And for our second triangle, area equals 1/2 base times height. Area equals 1/2, 5 times 1.9, and we get 4.75 kilometers squared. For this last example of finding the area of a triangle, I know the base, but I don't have a height. So I'm going to use what's called Hero's formula. You start by finding the semi-perimeter. Add all three sides together and divide by 2. And then to find the area, big square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. And then we simplify from there. So this is 11 plus 14 plus 20 divided by 2. So that's 45 divided by 2, which is 22.5. And then to find our area equals big square root 22.5 times 22.5 minus 11 times 22.5 minus 14 times 22.5 minus 20. So that area equals big square root 22.5 times 11.5 times 8.5 times 2.5. So the product of those is 5,498.44, and then we take the square root. Area equals 74.15 square kilometers. This slide is an example of the side splitter theorem. With the side splitter theorem, when 3 or more parallel lines are cut by 2 transversals, the parallel lines cut off proportional segments on the transversals. So for instance, AB over BC is equal to DE over EF. They're not all equal to each other, but they make equivalent fractions. So I'm going to call the distance from A to B x and set up my proportion. X over 3 is equal to 8 over 5, and then cross multiply. 5x is equal to 24, and then divide by 5. X is equal to 4.8. Given that 2 lines are parallel, there are all kinds of special angle relationships that will help us find a lot of missing angle measures. To start with, let's look at a pair of corresponding angles here. My given angle, that is 34 degrees, and angle D are what we call corresponding angles. They are in the same place on the same side of the parallel lines. They are both in the upper left corner of the point of intersection. Corresponding angles are congruent. Angle B and angle D are what we call same side interior angles. They are on the same side of the transversal and they are within the parallel lines. Same side interior angles are supplementary. So B plus 34 equals 180. So angle B is equal to 180 minus 34. So angle B is 146 degrees. Angle A and angle B are vertical angles. So they are going to be congruent. Angle C and angle 34 are vertical angles. So they are going to be congruent. And so they'll have the same angle measure. Angle B and angle E are what we call alternate interior angles. They are on opposite sides of the transversal, but they are within the parallel lines, and alternate interior angles are congruent. Angle E and angle F are vertical angles, so they are congruent. And angle D and angle G are vertical angles, so they are congruent.